Good afternoon, everyone, and a very warm welcome. Thank you for joining us. As we wait for everyone to join, may I request you to kindly keep your microphones muted throughout the session to ensure a seamless experience. Regarding the presenters, I just want to confirm that everybody is present. Mr. Deacon, so are you present?
Yes, I'm here.
Okay, thank you, sir. Mr. Ashok Chandar,
Yeah, I already connected.
thank you, sir. David, Sir David,
Yeah, I'm here.
okay, sir, thank you. Suraj Rangarajan, sir,
Yep.
thank you, sir. Kanchana, ma'am,
Yeah. Hello, all. Good evening. Nice connecting online.
good evening, ma'am. Thank you for your presence. Akshat Singh, sir, Akshat Singh, sir, are you present?
He'll be there. Yeah.
Sure, sir, thank you. Ayush Raina,
He'll join
I
them.
guess he'll join.
sure, sir, sure. Thank you, sir, thank you. Saurabh, Sir, are you
Yeah.
present?
Yeah, I'm here.
Yeah, sure, sir. Thank you. Thank you for your confirmation. Good afternoon once again. So we'll be starting the session in a bit. Good afternoon once again. Welcome to the pre-launch of the Hackathon 2026, organized as a part of SEMICON India. Organized by SEMI India and ESA, industry partners KLA and Applied Materials, academic partner Vellore Institute of Technology, hackathon partner I4C. We are delighted to have participants joining us from engineering institutions and universities across India, along with distinguished representatives from government, industry, and academia. Every technological revolution begins with an idea. Sometimes that idea changes an industry. Sometimes it changes a nation. Today, we begin a journey that has the potential to shape India's semiconductor future by discovering and nurturing the next generation of innovators. On behalf of the I4C, it is my privilege to welcome all our distinguished dignitaries, industry leaders, and academic institutions, faculty members, and students to the pre-launch of the Hackathon 2026. Today's initiative represents the coming together of industry and academia with one shared vision to inspire innovation, solve real-world challenges, and build the talent that will power India's semiconductor ecosystem. To formally welcome everyone and set the tone for today's event, it is now my honor to invite Mr. Deacon Denny Sir, Head Innovation and EC Member I4C, to deliver the welcome address. Mr. Denny, the stage is yours.
Thank you very much. Good evening, distinguished colleagues from SEMI India, ESA, our esteemed industry partners from KLA, Applied Materials, and our academic partner, Vellore Institute of Technology. Honorable Vice Chancellors, professors, and academic leaders, members of the semiconductor ecosystem, and to the young innovators who have joined us from institutions all over India. It is my great privilege to welcome each of you to the pre-launch event of the Hackathon 2026, organized as part of SEMICON India. Today is not simply the beginning of another event. It's actually the beginning of a conversation for all of us. A conversation about India's future, a future where India is not merely a consumer of technology, but also now a creator of technology. We are living through one of the most significant technological transformations of our generation. Artificial intelligence, quantum computing, autonomous mobility, next-gen communications, advanced defense systems. And every one of these technologies that I just mentioned is built on one common foundation: semiconductors. Semiconductors are no longer just electronic components, they are strategic assets, and they are now the digital economy engines powering nations across the world. They are becoming as critical to nations in the 21st century as energy was in the past. Recognizing this, India has embarked upon one of the most ambitious journeys in its history to build a globally competitive semiconductor ecosystem. But building an ecosystem requires far more than infrastructure. It requires talent, curiosity, problem solvers, and most importantly, it requires young minds who are willing to ask questions that nobody has asked before. That is precisely what this hackathon represents. It's about giving students the opportunity to work on authentic industry challenges, learn from global technology leaders, and collaborate across disciplines, and therefore then transform ideas into meaningful solutions. The pre-launch is a testament to what can be achieved when institutions such as yourselves work together with a shared commitment towards nation building. To every student participating today, you are entering this hackathon at a remarkable time in India's journey. The opportunities before you have never been greater. Some of you will build products, some of you will create good research, some of you will establish companies and go on to lead the semiconductor industry in the years to come. But regardless of the outcome, I encourage each of you to approach this journey with curiosity, resilience, and the confidence to challenge conventional thinking. As we begin this exciting journey, let's remember that every great revolution began with a single idea. Maybe one of those ideas is sitting in this virtual room today. Perhaps the next breakthrough could be emerging from one of the students who are joining us at this very moment in this on this very good afternoon. That possibility is what makes today's event so exciting. So thank you for joining us in shaping the future of semiconductor innovation in India. I wish everyone a truly engaging and successful event. Over to you, Suki.
Thank you, sir, for those inspiring opening remarks. It is now my privilege to introduce our next speaker, Mr. Sir Ashok Chandak, President of SEMI India and ESA. Mr. Chandak brings over 30 years of general management experience across the global semiconductor and electronics industry, having held senior leadership roles at some of the world's most respected names in the sector, including NXP Semiconductors, Philips, Infineon Technologies, and Motorola. His expertise spans sales and marketing, technology consulting, strategy, business development, channel management across distribution, EMS and ODM ecosystems, as well as company setup, M&A, spin-offs, design, manufacturing, and research. A seasoned cross-functional leader, Mr. Chandak has successfully built and led teams across geographic spanning over 40 countries. His domain focus covers semiconductors, automotive electronics, IoT, 5G, and AI with deep on the ground knowledge of India. He has served as ex-chairman of the India Electronics and Semiconductor Association and as ex-co-chairman of the FIDO Alliance, a global standards body shaping the future of authentication technology. He has also been an active startup mentor and incubator champion, guiding early stage ventures in the deep tech and semiconductor space. Ladies and gentlemen, please welcome Mr. Ashok Chandak. Sir, over to you.
Thank you. It was a bit longer, but it's okay. Welcome to everyone on the call, all our student community particularly and faculty. those are going to play important role in this hackathon. So, let me put a comment that two important comments first. Number one, semiconductor today is a buzzword which resonates more than Bollywood and Hollywood. Last year in the media, it appeared more than 12,000 times. And our Honorable Prime Minister and Union Minister keep saying it's a foundational technology. So the importance of semiconductor has been well understood within India to the masses and to the leadership. And this is where you are going to play an important role. Second point, the world as well as India has entered into a very different technology investment cycle. And this is a bit different than 4 decades ago, what we have seen with the IT revolution, where software and IT industry were carrying forward the industry. Today, the vectors have changed. There are multiple vectors or cylinders firing, which includes AI, electronics, semiconductor, the quantum, so forth. And many of these has got the semiconductor as a foundation technology. We know that Indian electronics market itself, as per our report, is going to increase to almost $400 billion by 2030, and a semiconductor demand of $103 billion, while as we speak, the global semiconductor industry itself has grown to almost $1 trillion. So things are much different. And this is where the huge opportunity is unfolding for the world and primarily for India, and you have an important role to play going forward. The second point I want to add here is axis. Second axis is very interesting. It's very unique. It has never happened before, I would say, for our sector particularly, is the several government policies, those have been rolled out by central government, particularly Ministry of Electronics and IT, and under the department ISM, India Semiconductor Mission, and various state governments are working hand in hand. They are very much synergized to create the holistic end-to-end impact. And not taking a technical jargon, but you should know this. There are several policies we call as the SEMICON India program, which is last year was been called as the SEMICON 2.0. New policy was announced last week. Then we have the mobile phone manufacturing scheme, electronic component manufacturing scheme, production link incentive, design link incentive, RDI, research and development, quantum, AI mission, so forth. And on top of that, several state policies. All these things are really working hand in hand, which I would call creates the free-wheeling positive spiral. It is going to create a massive impact of bringing India to a further limelight from today, which I would call as India has already built credibility based on what we delivered. And that is why this particular hackathon becomes very, very important, which is being organized as a part of SEMICON India event coming up into the September this year. Overall, I would say now India has earned a global recognition for a deep semiconductor design talent because almost 150,000 engineers are working, 20% of the global population. And as we accelerate our journey, a new journey which started in the chip manufacturing, where 3 plants are already operational and more going to get operational very soon, the imperative is very, very clear. India must expand its capability across the entire value chain to build a truly self-reliant ecosystem. And the various policies, and particularly last week's policy, has been very much instrumental in this and in the direction of creating that end-to-end ecosystem. And this hackathon, which I would call is really a deep tech hackathon, but a hackathon, has been conceptualized as a high impact platform to catalyze this transition, identifying, nurturing, fast tracking the breakthrough innovation in the semiconductors, but the intersection of the semiconductors, embedded systems, secure connectivity, and emerging technologies. By bringing together the brightest engineering minds, all of you, those are on the call, we are really looking at challenging the participants with finding a solution to some of the live problem. And this is where our sponsors come handy. Those are on the call and they will explain you more detail as we go along in this discussion. So overall, we are at a very decisive inflection point. While the India Semiconductor Mission is unlocking the unprecedented investment and being a catalyst for this journey of manufacturing and design in a semiconductor sector, the true multiplier will be the talent and a deep tech innovation. And that is why this hackathon is very important. So this hackathon would nurture and it will showcase the depth of the Indian semiconductor capability and the power of the young engineers to solve complex problems. With that, I would say all the best to you. Do participate in this hackathon with full of your zeal and will. Look into these real life problems. You would have opportunity, if selected, to pursue multiple levels of those gates, and our organizing team here would explain you how the things are going to progress. My understanding is we had a stupendous response in terms of the registrations, where more than 1,000 institutes have already, 1,000 plus student teams have already registered or shown the interest. Um, and this briefing session would give you idea as what are those industry problem statements are. And not only that, we are going to define the problem statement, but also we are going to get you the mentors so that they will help you in terms of solving that problem live. Thank you very much. Over to you.
Thank you, sir. This is now my privilege to introduce to our next speaker. Mr. Dominic David is the president of KLA India, where he leads the organization's growth as a center of excellence for software, algorithms, and AI solutions. A results oriented business leader with over 25 years of a KLA, he joined as a software design engineer and has since built a KLA India into a global hub of engineering excellence. Under his leadership, KLA India won the prestigious Strategic Planning Award. He has also been honored with the KLA BIA Exemplar Award by KLA CEO and holds multiple patents for inventions in semiconductor measurements. Ladies and gentlemen, please welcome Mr. Dominic David, President KLA India. Sir, the stage is yours.
Okay, very good. Welcome everyone to our 2026 hackathon. Let me just quickly give a 1,000 feet view first. In case you're new to this whole space, we keep saying semiconductor industry. What we mean is a whole bunch of companies that are chip designers, chip makers. There are machines that are needed in the process. We call them as equipment makers. Then there is a lot of materials and gases that go into it. All put together is the semiconductor ecosystem. Now, I'm part of a company called KLA. We are a semiconductor process control equipment maker. Well, that's a lot of words, but to put it very simply, these chips are very smart, very expensive, and very hard to make. But at the heart of these chips, there are very tiny elements, transistors being printed. Nowadays, you are printing, the smallest structure is about 1 to 3 nanometers in size, right? If you're wondering what that feels like, a human hair is roughly 50 microns thick. Now you go down from microns to nanometers, we are in the space of 1 to 3 nanometers. Now, a fun fact, every chip that has ever been made has gone through a KLA machine, which means every phone and laptop and every electronic equipment that you are already using has a chip, multiple chips, and all of them have gone through a KLA machine. So you're already using products touched by KLA, but you just never heard about it. So we make machines. KLA makes machines that enable the factory, the chip makers, for example, an Intel or a Samsung company that makes the chip, they make these very tiny structures. They need to be able to see it. Our customers basically say, we are blind without you. We can print these very tiny structures, but we're blind, right? So KLA's machines helps them to see and measure. Bottom line, we are a super high resolution microscope. If you want to simplify it a lot, that's what our machines are. And there's a lot of automation around it. These machines are used to go find problems in the chip while the chip is still being made. When it's fully done, you can put it on a printed circuit board, a motherboard, and test it, but that's too late. It's like you're now finding out some of the structures are not okay after constructing a 100-story building. That's too late, right? So you have to find the problems as the building is being constructed at every floor. That's what our machines help us to do. Did I tell you that every chip that has ever been made has gone through a KLA machine? That's what excites us. The semiconductor talent needed to go take care of this industry, and particularly a company like KLA, which is the leader in this segment, in this industry for over 50 years, is we need algorithms, we need high performance computing, we need AI engineers, software engineers, and so on. Right? And the specific areas of focus often are statistical algorithms, image processing, signal processing, deep learning based work, and computational physics. And there's a lot of other physics and math that's involved in this space. All of that put together, we are able to create a machine that pretty much encompasses every field of engineering you can think of. The machine is roughly the size of a large bedroom, and it would cost our customer anywhere from $1 million to about $50-60 million per piece. Right? So that's just giving you a scale of what it costs, how big it is, and how tiny a structure it looks at. Finally, the expectation from all of you is we're going to give you real world complex problems. And both of us and the next presenter from Applied Materials, both of us are going to give you real world problems. Our expectation is that you take this as a learning step and you go back to your education and find real world complex problems to apply your learning. Textbook lab is just not sufficient. We'll need to be able to apply concepts from so many different fields into one problem, into a narrow space, and crack that problem. That's what helps us to be able to innovate in this space. Semiconductor industry is a hotbed for innovation that is making every chip smarter, smaller, cheaper, and more energy efficient. And KLA is one of the companies that's enabling this innovation a lot. So remember, every chip that has ever been made has gone through a KLA machine, and you're going to work on a problem that we solve today. Thank you all.
Thank you, sir. It is now my pleasure to introduce Mr. Suraj Rangarajan, Principal Technologist at Applied Materials India. Mr. Rangarajan holds a BTech in Metallurgy from IIT Madras and a PhD in Materials Science from the University of Texas at Austin, a foundation that has anchored a remarkable 25 plus years of career at Applied Materials, where he began as a process engineer in Santa Clara in 1997. His progression through his roles spanning product marketing, group head, CTO, and managing director reflects the full breadth of semiconductor process engineering, product strategy, and India leadership. He currently leads the Semiconductor Products Group at Applied Materials India, driving strategy, ecosystem partnerships, and the development of India's next generation of semiconductor talent. He has been a prominent voice at industry forums on digital lithography, semiconductor packaging, and materials innovation in India. Sir, over to you.
Thank you. Thanks for that very kind introduction. So I'll try to use some slides and I'll try to double down on a lot of what David said. Thanks for that good introduction about semiconductor and also our industry, the semiconductor equipment industry. So let me just uh, switch to this. Okay, can you see my slides?
Yes, sir.
Yes. Okay. I have, it says 63. I'm not going to do 63 slides. I'll just use a few just to give a sense of what the company is and what the industry is so that you get a sense of the domain, right? The skill sets that you bring are things that you own, but you also need to get a sense of where you're going to apply this in the semiconductor industry. Like a lot of California-based industries, this was our company was born in a garage in Mountain View, 1967, and this is our office in Whitefield. So this is ITPL in Whitefield. So we have close to 9,000 employees here, and you can see there is the applied bug that the employees made over here. This was in January this year. Big Fortune 500 company, about $28 billion. So this slide is important just to give you a sense of what we make. We make machines. And if you see at that very left corner, you can see some people, right? And this is a machine that we built. This machine actually makes the um, glass panels that are used to make your LCD TVs and OLED TVs. So that size of one of these is about 3 meters by 3 meters. So this is the scale at which the industry operates, right? For semiconductor, we use 300 millimeter wafers. For display, we use much bigger substrates. And in all of these, we deposit thin films that are at the angstrom level. So one of the things the industry does is it can take angstroms and apply it at industry scale. And that is where we need a lot of help and support to be able to do this. I'll talk about 3 things that are very important for us and for the industry. And this also will tie into some of the things when we talk about the problem statements. As an industry, it is very important to be able to innovate. Next to healthcare, semiconductor is one of the very high R&D intensive industries, close to about 15 to 20% of the revenue. So if you make $100, $15 goes back into R&D, and that R&D continues to be changing all the time. So we need, like, every 2 years you buy a phone. So every 2 years we need to innovate our products to make new things. So that's one of the reasons why we are reaching out to students to come up with new ideas. The second part is this high velocity collaboration. Semiconductor is a very interdisciplinary industry. We need physicists, engineers, mechanical engineers, software engineers, algorithm, uh, and people from various parts to come together. So in this case, we are trying to work with the ecosystem and how do we collaborate faster. So you can see right now with AI, things are accelerating so fast. You keep seeing new models now almost in the space of weeks. The hardware that goes with that also needs to be upgraded, for which up and down the chain, the semiconductor stack needs to be able to talk to each other and collaborate. So that's one thing that we are seeing a lot more, and that's one thing that will also change how the industry operates. Accelerated commercialization. So a lot of the R&D that we do goes into product. So this is sort of applied R&D. So one of the things, this sort of gives you a sense of the industry, very innovative, uh, collaborative, and very applied R&D focused. So that gives a sense of the semiconductor industry. Very global, all over the world. And yeah, we manufacture in Austin and Singapore, and we have R&D in different parts of the world. Okay, I'll just do a couple more slides just to again give a sense of semiconductor. So this is important to where are you applying your skills, right? So you see those things here, which all of us should now be very cognizant of: data center, edge AI, electric vehicles, renewable energy. A lot of these are these big industries. All of these are in the trillions of dollars. The foundation of all of this is semiconductor. So any innovation that you make in semiconductor will have a big impact in all of these industries. So there is something in the industry called PPAC now. Earlier it was Moore's law, where you kept shrinking and the cost would come down, performance would go up. Now, in addition to this area cost AC, we also need to track power and performance and also time. So the time to market is also a critical element. So these are all things that the industry now cares about a lot. So one more thing, just from um, where we are today, a lot of the AI that you consume is at the cloud, right? You type stuff, answers come back, everything is at the cloud. One thing that's going to happen going forward is that things will come closer to you. You will get a lot more physical AI that you can touch and feel and use at your fingertips, more at the edge. Uh, this is the number that all of you should care about a lot. The semiconductor industry today is $1 trillion, going towards $2 or $3 trillion over the next few years. A lot of this is powered by AI. So this is an industry that all of you should look forward to in terms of both size and growth, complexity and challenges. So let me talk about a couple of challenges and then I will stop right now. The biggest challenge that we have today is energy efficient compute. Basically, how much energy it takes to do stuff. So every time you type something on your LLM asking a question, the energy consumed by that is today it's about 2% of the world's electricity. It's going to go to about 12% of the world's electricity in a few years. Now, one of the big things that all of us, all the different things that we are asking people to do eventually is to try to see how we can reduce this energy load. That's because the current rate at which things are going is not sustainable. So we have a lot of innovations that we and the industry are doing to bring this down. And I think, yeah, I will probably use this as my last slide. In terms of innovation infrastructure, a lot of what we do requires hardware, requires machines, and expensive R&D. We do a lot of investment. About $3 billion of our revenue goes back into R&D. We have R&D centers all over the world, in the US, in Singapore, and we also have a Applied Ventures arm, which invests in deep tech startups. So one of the things that a good outcome of this can be, you come up with something so innovative that our startup, the Applied Ventures, is even interested in what you're doing. So thanks a lot. Thanks for being part of this challenge. And what I wanted to convey from these slides is semiconductor is a big industry. It is a growing industry. It's an industry where we are looking at innovations. We want you to solve problems that we have so that we can continue to do this innovation cycle that we have. Thanks.
Thank you, sir. It is now my honor to introduce Dr. V.S. Kanchana Bhaskaran, Vice Chancellor of Vellore Institute of Technology. Dr. Bhaskaran is an academic leader of exceptional distinction with nearly 40 years of experience across industry, teaching, and research, holding a bachelor's from IE, a master's from BITS, and a PhD from VIT. Her areas of specialization include VLSI design for low power, microprocessor architectures, and linear integrated circuits, fields in which she has published over 140 papers in international journals and conferences, and holds 3 patents. She has authored 4 books on linear integrated circuits published by McGraw-Hill Education and has served as a Dean of Academics at VIT Chennai. Prior to her current role, a Fellow of IETE, a Fellow of Institution of Engineers, and a Senior Member of IEEE. Dr. Bhaskaran is one of India's most respected voices in engineering education and research. Ma'am, the stage is yours.
Good evening, all. It's a great occasion, really, to be part of the SEMICON Hackathon 2026 SEMICON India event. And in the launch event schedule, many speakers have already talked about, and all the topics and all the contents should have been very useful for all the academics, the students who are actually participating in this. It's a great initiative. I should appreciate all the enablers and all the participants, the sponsors who are creating this event, who are making this event so big. And for India, as had been told by many people, we have electronics, the semiconductor, to be a great thing. Right from academics, right from industry, right from applications, everywhere, electronics rules. Whatever be the application, we have the semiconductor to be part of it. And so far, we had been importing the semiconductors, and we had been having the machines also imported. So, as an academic, what we have got to do, we have the biggest tertiary age population, we all know, and they are in the institutions like universities, other colleges affiliated, and all that. Their participation and their getting ready is going to be really defining what the future is going to be holding up for India. And this is such a great step. That is why the Hackathon 2026 being part of SEMICON India event. When we consider the semiconductors, right from the vehicles, we had automobiles on the road, right from 20% to the smarter it goes, you have even up to 80-90% of electronics there. And we have all the sorts of engineering departments in all the institutions. So if I take an automobile on the road, if you have more than 40% embedded electronics in it, communications in it, sensors, IoT, all those available in it, along with security also, now there becomes the necessity for a multidisciplinary learning. By multidisciplinary learning, not just by the textbooks available, because for the sort of exposure what we have got for the students to learn and the technology evolution, what is happening, we cannot depend only on the textbooks. We have got to take into account what dynamically the industry is doing, and that should reflect in the academics also, right from our curriculum, the curriculum in which what we offer as the standard subjects. In addition to that, we have got to have a holistic learning given to the students. That is where we have our institutions with a very big responsibility of enabling experiential learning and multidisciplinary learning in that. And institutions really can go for AICT, UGC have been really giving encouragement for that, right from minors courses, for example, on semiconductor engineering, electronic system design, or semiconductor manufacturing for that matter, embedded system design, and even computer architecture design also. All these ought to be evolving in the institutions, and the students should go for taking opportunity. They should go for craving for such subjects what are offered by other institutions or their own institutions to learn and practice. But the practicing also is going to be something what each and every institutions cannot afford to. Lot of institutions, I should at this point of time thank through the chip to startup, the availability, the exposure, access to all the electronic design automation tools what are given to the institutions, and through that we are actually making a very big headway into learning and practicing and all. I think these manpower what we are generating at this point of time are going to be the people who would be working with such industries. As told already, we have 3 plants already coming up who have already started generating the tangible outcomes, and we have many more such facilities which are coming there. And in addition, whatever be the semiconductor related components, right up to the power electronics, or what we can use as embedded electronics in all the chips and all, we have got to be creating here. as one person pointed out, we have more than 20-25% of the global design happening is there happening only in our country. And we have got to, at this point of time, in addition to being designers of the IPs created by foreign countries, we have got to develop direction. We have the PLI scheme encouraging the components to be manufactured inside the country itself. And in DLI, the design of such things also, we have got to have that concentrated upon. And we need to, right from AI chip design, edge computing, and we have a very big ambitious missions were several announced for that matter, right from semiconductor mission, quantum mission, national quantum mission, and you have India AI mission, and for cyber physical systems, interdisciplinary, all where we have got to have the semiconductors playing a very major role. Therefore, right up to GPU design, right up to application specific integrated circuit design, the students are to be given exposure. Therefore, at our institute, we do this. Several minor program on these topics, what I have opened, all these are there. And we encourage all the engineering students, right from computer science, right up to mechanical engineering students, with their material science knowledge, right from, as already told, you have the heat dissipation to be a very major thing. So right from the materials what we use, right from the chemical knowledge what has to go into it, the physics with respect to the quantum, and the packaging with respect to the heat dissipation and all these are going to be great topics what the students have got plenty in front of them. I want to have all our young students who are there in the colleges, who are doing undergraduate, postgraduate courses, to really make use of the situation what is emerging in our country, with so many inputs given by all the industries who are participating here, and the right climate from the government and also from all the states and center. This is a great opportunity for the whole country, and the first beneficiaries are going to be the tertiary age population, what we have in front of us, and they are going to be really making all these things, making Vikshit Bharat play a very major role in that. Therefore, we cannot define very simply what are going to be the opportunities. Wherever you see, whatever you use, you find some part of semiconductor in that, and that semiconductor is growing. How each of the students and the teachers are going to be familiarizing themselves with how they can go for contributing to such an ecosystem which is evolving. That is going to be the order of the day, what we have to really focus on. I hope all these activities by IESA and all are appreciated and really made use of by all the people concerned, all stakeholders. It is a great time for the country. I think we will go for winning. Thank you.
Thank you, ma'am. Every innovation
Thank you.
begins with a challenge, and solving that challenge requires minds trained at the intersection of engineering rigor and real world impact. I now invite Mr. Akshat Singh to present the first set of hackathon problem statements from KLA. Mr. Akshat Singh is a senior analyst in algorithm development engineering at KLA India, where he develops next generation AI and machine learning solutions for semiconductor inspection and process control. His work spans advanced computer vision, vision foundation models, and high performance AI systems that improve defect detection accuracy while reducing dependence on large labeled datasets. A BTech graduate in computer science from IIT Madras, he brings both academic rigor and deep semiconductor industry expertise to the challenges he works on. Mr. Singh, the stage is yours.
Hi everyone, good evening. Thank you for the introduction. Let me share my screen and my presentation, which I had for this. Okay, So this is a overview of the problem statement. Uh, the title of the problem statement is Restoration of Degraded Images, and this is a high level overview. So the challenge at a glance is to develop AI solutions to restore signal degraded images. What I mean by signal degraded images are the following types of noises. The first one is speckle noise, then there's Gaussian noise, and then there's reduction in spatial resolution. So these are not arbitrary noise or arbitrary signal degradation that are happening to the images. These are in fact something that we see in the real world. For example, like the previous speakers told that with manufacturing moving to 3 nanometer, 2 nanometer, and even angstrom scale, when you try to analyze or you try to find defects or you try to manufacture and you want to image these things, a lot of effects come into play. Some of these effects are like interference of light, sampling error, sampling noise, etc. And these errors and these effects cause a lot of noise in the images. For example, interference of light actually causes speckle noise to happen. Sampling error can cause Gaussian noise to happen. And then there's reduction in spatial resolution. The goal of this hackathon is that given these noisy images, can we create an AI model to reconstruct these images to their original or near original state? And essentially, the goal is to reduce noise in these images and to increase the spatial resolution. So, a question that arises is why this matters. This matters because image quality is critical in precision measurement and inspection, especially when you're measuring or when you're manufacturing or when you're inspecting such small scale structures. You want as much information in your images as possible, and you want to reduce the noise as much as possible. Signal degradation, like you will see when you are participating in the hackathon, can cause measurable information loss. There are different ways to measure how much information you're losing, and there are ways to visualize this as well. Intensity histogram is one such way where you can look at the histograms of degraded versus ground truth images. Speckle noise is especially challenging to deal with because it's a multiplicative noise and it can push the pixel values beyond the ground truth range. AI-driven solutions here can enable the recovery of fine spatial detail, which is lost during downsampling. It can suppress the speckle noise across diverse image types, and it can enable broad generalization across multiple image distributions. And the idea for a good solution is that instead of just being accurate, it should also be computationally efficient. So this is a sample example of what the training data can look like. On the left, you have the ground truth image. Let's say the size is 5112 cross 5112, the X and the Y dimension. And we can see in the noisy image, there's some degradation that is happening and it's been downsampled as well. So instead of the size being 512, the size is 256. And from the intensity histogram, we can see that the blue region, which is the ground truth, has some extra information which has been lost in the orange region, which is the noisy LR. And the idea of this hackathon or the goal of this hackathon is to create an AI model to go from the noisy image, which is noisy LR, to a denoised image and an upsampled image, which should be very similar to the ground truth image. A quick look at the data set, which will be given as part of this hackathon statement. So the training set, which will be used to train the AI models, will have pairs of degraded and ground truth image. The ground truth image will be 5112 cross 5112 pixels, and the degraded images will be lower resolution 256 cross 256 due to downsampling. And the images in the training set come from different data origins, different distributions. They can be buildings, animals, some other structures, etc. So it's been given in this way so you can create a robust model which is diverse enough or generalizable enough. And the test set will include some in distribution images, which means these images are very similar to the images on which the AI model has been trained on. So it's expected to perform well on these images. In addition to in distribution samples, we also include some out of distribution samples, which the model has never seen during training. And this helps evaluate how good is the generalization of your model. How well does the model perform on unseen images, unseen distribution? Because um, even though the data is scaling and the data capacity of these models is improving, it's not always possible to have representation of all the different types of sample images that you'll see in your train set. So you want to focus on developing solutions which are not overfit to the training set and can generalize to different image types. So this evaluates both accuracy and robustness of the solution that you will develop. Here's a quick summary of the evaluation that we'll do. So the submissions will be scored on 2 dimensions. The first one is restoration quality. This is how good are the image reconstruction which your model is able to do. And the second one is end-to-end inference time. So the first one around quality metrics, there are a lot of metrics you can use to measure. There's a lot of metrics you can use to even train your model. Some of these metrics are listed here. So there's structural similarity metric, SSIM. There's peak signal to noise ratio, PSNR, and there's learned perceptual image path similarity, or LPIPs. And faster and well-optimized pipelines are preferred when the quality between two different AI models is comparable. Because there's a cost associated to deploying AI models. You need, if you create larger and larger models, even though they offer good accuracy, you have to pay the cost of inference. For a larger model with very small increase in accuracy as compared to a smaller model is not very preferable. It's always preferable to have the smaller model with a better accuracy score. So this is all I had on the high level introduction to the problem statement. Thank you.
Thank you, sir. We now invite the Ayush Raina, Senior Algorithm Manager from Applied Materials, to present the next set of hackathon problem statements. Sir, over to you.
Hi, good evening, everyone. Thanks for the introduction. And uh, I guess I was very impressed with the previous problem statement as well. Thanks, Akshat. So we welcome you to for this second problem statement introduction. I'll try to give some sort of a teaser for this problem statement. We will have time to discuss it in depth in subsequent days. You will have support from the I4C team as well as from someone representing Applied. And we will discuss these problems, data sets in depth. Okay, let's go. We are talking about something called as navigation error. So if you see generally the chips as per the introductions given by the previous members, we see that we have wafer, on wafer you have dies, and generally you have something called as reference, and you're looking for to grab some image to basically see whether it has been created well or not. So let's say over here you have a mark called plus sign, which we are trying to grab an image. You see a box here in cyan color, and the star basically tells that it's a reference. Now, our understanding is that all dies will have a similar pattern, and that's the reason why we see that we are hoping that if we go to another die, we will basically see the same pattern again. Okay. Now, but what actually happens is, like, since our wafer is mounted on a stage, and due to some, we can say, drift on the stage motors, there is vibrations and there is thermal effects, we actually don't land up at the exact spot. We land up somewhere a little bit far from there. As a result, if you try to grab the image at that location with same zoom, we will not be able to get the actual target, or basically the actual place where we intended to go. So this is a problem which is we call as a navigation error. Okay. So now let's see it again. We have some target at one place. We basically take generally a reference image at this place. We want to go to another die, grab an image there. But due to some navigation error, we basically shift out to some part. Now, in general, as a human, like you will always do it with Google Maps, you will try to zoom out from it and then try to figure out where actually you are, and you would like to correct yourself. Similar thing we want to do in this problem statement. So it's a pure imaging problem like before Akshat introduced. In this case, we are trying to find a bigger pattern, which we discussed as a reference on the left side. And when you try to basically zoom out from that location, you will basically see it very small. There are 2 samples here, and there is, you can say, a couple of samples here as well. So these are generated data. They're not actually what we see on customer images, and these don't have noise models also. It's very simple. But to understand the problem, I made it this way, that you can understand that how a reference image would look like and how a zoomed out image will look like, and you have to search it. Okay. So our understanding would be that let's assume you have 2 microscopes, and one is you have one zoom at 10x and you have 100x. So the left one is your 100x and the right one is your 10x zoom. Okay. So to simplify the problem, we have made it this way, that you will always have both the images at 1000 pixel by 1000 pixels. And you're trying to search the pattern on the left, downsample it, and then search it in a wide search form. Okay. This part I already explained. On an optical tool, you will see some pattern like this, and you will see this is the more zoomed out pattern on the left. Same thing, we are doing something on a grayscale image to simplify. And you have to provide first center XY of the first matching tile. The same pattern could be present at many places. You have to find it something which is closer to the reference image center. Okay. So classic methods as hints could be cross correlation. You can have more optimized ways when you do the literature survey. And you have some classical methods, and you also have some deep learning methods to solve these problems. So as I explained, both images are 1000 by 1000 pixels. We assume that you will have in the image on the left, 1 pixel is representing 1 nanometer. Why we're saying is because the data set will also respect some nodes. The structures which we'll create using augmentation will respect some of this similar architecture. And on the right side, your 1 pixel would represent 10 nanometers. It's a 10x part. Okay. We will help you around with the dataset creation. Since this industry is very close IP, we will try to give you some synthetic datasets or codes to generate those synthetic datasets. But feel free, you can test your algorithm on existing data, which is available. We'll try to give you something public as well as to do the course. But the original dataset for evaluations, for test evaluations and in-house evaluation, we will share them again later to you. So our expectation from you would you to help also to understand like how good are you to understand the industry. So for that, we want you to able to generate some synthetic data sets like I created in some images before. We would like you to have some augmented data set created. You have to justify the augmentation, the noise models which you are adding. Let's say Akshat discussed earlier about the speckle noise. In our cases, we generally see in SEM imaging, we will see more of short noises. You will have distortion, you will have scaling in the structures when you zoom out in the wide search. So that will create issues for you to register and find the right location. And then the main crux is the third line where we want you to report where actually the pattern is. And again, another factor which you want is the computation time of your algorithm, how many passes it takes over the image, and see it on some at least 30 samples, understand where it passes, understand where it fails, and we'll work it together with you. Also, the bonus part, if you have algorithm which is stable towards RGB images as well, not only the grayscales, that is even some bonus marks which we want to award, or like, okay, the problem has been generalized enough, the solution has been generalized enough, which can work for both methods, both kind of domains. Okay, so I guess there are FAQs which we will discuss it later when we'll have in-depth session, but this is all we wanted to present. You will have some sample prompts, some repositories which we will share to help you to generate this augmented data from RT. And yeah, that's it. That's it from my side.
Thank you, sir. We now thank you to both our industry experts. I invite Mr. Saurabh Uble, Innovation Program Manager at I4C, to guide everyone through the hackathon process. Over to you, sir.
Thank you, Kushi. I welcome everyone to the pre-launch of the hackathon once again. And we will quickly walk you through the hackathon process, the timeline of the hackathon, what do you have to submit, who are eligible participants to participate in the hackathon, what are the prizes money, most exciting part, and what are the other opportunities that students will get from this hackathon. So as we pre-launch this hackathon today, so the registration starts on 24th of July, as you know. From 24th of July till 16th of August, we have registration and submission period. So to last date for the round one submission is 16th of August. This date will be strictly monitored. Then in between 30th July to 12th of August, we'll be doing webinars and knowledge sessions. We will deep dive into the problem statements. We will explain you the problem statement through webinar sessions. We will give you sessions related to the concepts that are involved in the problem statements, which will help you to build the solution or come with the right solution. After that, from 17th to 27th of August, we'll be evaluating your submissions, and then we will be announcing the top 15 teams per problem statement. So as you know, like we have two problem statements. So each problem statement, we will shortlist 15 teams. So total of 30 teams will go for the round two, that is phase two of the hackathon. From 28th to 4th of September, we'll be doing a phase two submissions and evaluation of the hackathon. By 5th or 6th of September, we'll be announcing top 10 finalists. That is 5 teams per problem statement, which will go for the grand finale. And after that, we'll be doing a mentoring sessions for each team from 7th to 12th of September. And we have the grand finale on from 17th to 19th of September at SEMICON India in New Delhi. That's on the timeline. Every other detail which I'm presenting, or which many other details have also already been shared on the landing page of the hackathon. We will also share you the link. Okay. Yeah. So prize money. So the total prize pool is about 4 lakh rupees. So we have two tracks. So each track, that is each problem statement, will have two winners. One is winner and the runner-up. So winner gets 1,25,000 rupees and the runner-up gets 75,000 rupees. And many other opportunities may come to you during the grand finale. Coming towards who can apply. So this hackathon is only open for the students who are undergraduate or pursuing PG from any domain who are interested in applying for this hackathon. So whether you are from BTech or any other streams like AI, ML, electronics, or mechanical, you can try to attempt to register for the hackathon, give solution to the wonderful problem statements presented by KLA and Applied Materials. The team structure, so you have to register as a team of 2 to 4 members, is mandatory. You can have people from like interdisciplinary team. So you can have team member from coming from AML department, or team member coming from electronics department, and any other department. So the two phases of this hackathon are online, and the grand finale will be offline, as you know. There is no hardware involved as of now. The evaluation, so basic evaluation criteria like innovation, technical feasibility, depth of solution. So problem statement, how good you understood the problem statement, then potential impact. So your solution does that is create impact, does it solve the required problem given by the industry? And of course your working demo at the grand finale. Yeah, so what you have to submit is like a pitch document, which we will share, which is also available. The idea submission template is also available on the landing page. Data set as required, whatever data or documentation as asked for the problem statement, you have to share, and also your repository like GitHub repository or video link to be shared on the portal. Yeah, so coming to it's how to register for the hackathon. So first step is to register yourself as a team captain. Can have a one member selected as a team captain for the hackathon. Then you have to form a team. You have to register your team on the portal. Then pick a problem statement and do a submission for that. So well, now I will walk you through the registration process. So when you go to the landing page, you get all the details over there. I'll show you the landing page where you will get the registration link and submission link. So once you click on the registration, you get to the portal where you have to register yourself, register your team, and submit the solution. So you have to register, you have to create your account, create your profile, fill the basic details as required, will be authenticated through your email ID. Then you have a further process of you have to register as a team, then as a team captain. Then as your student, you have to select student, uh, create your profile. Once you create your profile, your account will be get created and you will be able to log into your dashboard. So once you log into your dashboard, you have two cards like submit a new idea. Now, as you have registered for first time, you have to do the submit your new idea. Once you click on the submit your idea, you will go to the team registration. So you have to register your team members, fill the required details of your team members, and then you'll go to the selection of the problem statement. So you have to select your problem statement. So we have two problem statement for this hackathon. So you have to select one or two, one or the two. You have to upload your particular document in form of PDF. The submission document, you have to upload your GitHub repository. If you have a video link created of your demo, you have to upload that and then submit. Then you have a manage idea section where you can check whether your ideas is not submitted or not, or if you want to edit or delete or resubmit again, you can do it through it. Yeah, I'll now just give you a glance of the landing page where you will have all other details. I hope my screen is visible. So this is the landing page of the hackathon you all been asking in the chat box. So we have all the details given it here. You have a register button. As I told you, when you click on the register button, you will be redirected to the portal where you have to register for the hackathon. All the documents will be shared on the landing page itself. So we have all the sections. So we have problem statement listed here. More details will be added to the problem statement, uh, which are required to be shared. Like we will add the PPT, we'll add other more details, data set to it. Then we have the timeline displayed on the landing page. We have the prize money given to you and any other things. Eligibility criteria. Then you also have the resources. So you will get the idea submission template, you will have the registration process document, we will share the hackathon brochure, and also we'll share you the problem statement explanation. So all the links or the webinars that we conduct will be hosted on the landing page. Yeah. And we have also given all the accounts, uh, LinkedIn accounts of all the members where you can which you can follow and stay updated. We also have the WhatsApp group link which you guys been asking for longer time throughout the session. So that is also been given here. So you can scan or directly join the WhatsApp group. So WhatsApp group you will only get the updates. Any questions you have to write uh, through our email ID. So now we are open for the 5 minutes Q&A. If anybody has questions, you can raise your hand and we will unmute you. Or you can put your questions in the chat box. So this will be only 5 minutes. If you have any other questions, we have given you the email ID for the questions in our chat.
Shaurabh,
Yes, yes.
can two students from different college join as a team? That's the first
Okay.
question.
We prefer to have the student from same college. So we have allowed Abhishek to speak. So Abhishek, you can unmute yourself and you can have your question, please. Nikhil, you've been allowed for the question. You can ask your question if you have.
But Shaurabh, I think their chat, they're putting in the chat bot, you can answer like that only. Can students from BTech and MTech can join as a team?
Yes, from the same college, they can join. Student, yeah. No, you have to be, so you cannot participate alone. You have to be, have to have a team. At least 2 members.
Maximum 4 team members, not more than that. 2 to 4, it is very clearly given in his presentation. Once you register,
Problem
we'll have a
statement.
separate session on a problem statement. It'll be a deeper explanation will be there. So if you want to register whichever problem statement, you can register and you will have a invite for the problem statement in a deeper session will be there. And one team can access only one problem statement. They cannot participate in both the problem statement. Shaurabh, can you just check the chat bot? Questions are there.
Yeah. So you all will get the hackathon landing page link. It's also, you can also search for the hackathon on Google. You will get search for the semiconductor hackathon 2026. You will get the link. Also, it's available on i4c.in. You can go to i4c.in and then you will get the like a hackathon landing page. Team members, we want to take VLSI domain problem statement. That if another team take cover. Everybody is allowed to take any problem statement, so that's not a problem. Okay, so if you have any questions, just put us to the support@i4c.in, or you can join, or you can put the questions in the chat box. We will answer. So we will move on to the next session.
Yeah. Yes, Saurabh, we can move on.
Suki, over to you.
Thank you. Thank you, sir. So to bring this, we will now, okay, to bring today's session to a close, it is my honor to invite Sir Deacon Denny for the vote of thanks.
Thank you. Great, great. So good evening, everyone, once again. As we come to the close of the pre-launch event for Hackathon 2026, organized as part of SEMICON India, it is my privilege to propose a vote of thanks. On behalf of I4C and everybody who's over here today, a heartfelt thanks to Mr. Ashok Chandak, Mr. Dominic, Mr. Rengarajan, Dr. V.S. Kanchana Bhaskaran ma'am, Akash Singh, and Ayush Raina for your second explanation of problem statements and overall sharing valuable insights for all the students over here. Want to thank our esteemed partners once again, SEMI India, ESA, KLA, Applied Materials, VIT, and of course, our entire I4C team for their collaboration in making today's initiative possible. Special word of appreciation to everyone who presented the hackathon challenges and processes. So Akash and Ayush, giving participants a clear roadmap for the exciting journey ahead. It was very well presented. And most importantly, thank you to all the students. I see a lot of questions popping up. Please do write into us. If the WhatsApp group is full, we will accommodate you. We'll create another WhatsApp group as well. We'll take care of all your queries. Don't worry. Please check the landing page for the schedule of affairs and how to register. Any issues, you can write into support@i4c.in. Once again, a big thank you to all the faculty members, researchers, and participants from across the country. Your enthusiasm will be the driving force behind this event. And we look forward to seeing great ideas coming through from this event, which has been launched today. Thank you once again on behalf of I4C, and we wish you a wonderful evening. Thanks, okay.
Thank you all. Thank you, everyone, each and everyone. Thank you so
Thank
much.
you, sir. Thank you all.
Thank you very much.
I
Thank
wish you all a very great event.
Thank you, ma'am.
Absolutely.
Thank you. Thank you.
Thank you. Thank you.
Thank you all.
Thank you. Thank you, Saurabh.
Saurabh, we can close the event, no?
Yeah.
Yes.
Thank you. Bye.
Thank you. For all students, please remember, write it to us on our email ID. Don't worry about your WhatsApp. We will help you with accommodating you with different channel. We'll ensure we take care of all your problems. But before you ask us any questions, it'll be great if you can just go through the FAQs once to save time for yourselves and for us as well. Most of the questions are very FAQs are very self-explanatory, and at your level of intelligence, I'm sure you guys will figure it out. But if you have any difficulty, we are always here to support you. Thank you so much, guys. Have a great weekend, and please register over the weekend, guys. Thank you. Thank you, Viswas sir. Bye-bye.
Thank you. Bye.